Hello everyone. Here we're going to be talking about a general competitive equilibrium. Now, what we saw in a previous video was that we had derived the price offer curves for Adamo and for Beatriz, our two traders, and we had seen that at a given price, we did not have a market clearing equilibrium. Instead, what we found was at that price, Adamo was on the short side, Beatriz was on the long side, and we had a non-clearing market. Demand did not equal supply for the two goods, data and coffee. Okay, so let's proceed from here. We're going to use our insights from earlier about the price offer curves to understand how to find a Nash equilibrium. This Nash equilibrium is going to be a Pareto-efficient general equilibrium. Now, what that means is that neither trader is going to want to deviate, and each is going to be mutually best responding to the other one. So let's think about how we can find that. Here we have our thinking about the Edgeworth box. And the first thing to see is that we've got point N over here, and we have point Z over here, point Z or point Z. Now remember that a Nash equilibrium is a mutual best response. So what we have to then think about is, why must the Nash equilibrium be a point on each of their price offer curves and shown by point N? That's the question we have to ask ourselves. Well, let's think about it in the following way. We know that every potential price that could result in a trade must first of all go through point Z, through point Z. Now, every potential price that does that is a price which is basically a line going through point Z and having a different slope, showing the different rates of exchange of the two goods for each other, as we've seen in chapter 4 and here in chapter 14. Okay, so thinking about those rates of exchange given by the prices, we can now think, why is point N a mutual best response? Well, let's think about the price offer curve. The price offer curve tells us every utility maximizing point for each of the two people when they are thinking about their utility subject to a specific price line. So the price offer curve is saying each utility maximizing point for every potential price they could be offered. Now what this then means is that the point at which their price offer curves intersect, such as point N, will be a mutual best response. It is a price that is taking them from point Z to a trade that will take them to point N. So that trade is one that moves them from one point to another point. Now, let's think about this. Is this point going to be a mutual best response? What we can see here is that it's going to be one where A's demand for Y is going to equal B's supply of Y, and A's supply of X is going to equal B's demand for X. So we can see that by seeing here, if we move down by our points and we look at the amount of X that A is willing to provide, that would be here. That's the amount of X that A is willing to sell to B. And we can see equally that if we look over here and we go up, that this amount of X is the amount of X that B would demand at that price. So demand is equal to supply. We could do the same thing for the amount of good Y at that price, and we would see again that demand equals supply. So what that tells us is that demand equals supply at this point, and that point N is a mutual best response. Neither person is going to want to deviate from that point, because if they had a different price than this one, they're not going to want to they're basically going to either demand or supply less of the goods at these points, less or more. Now then the next question we can ask ourselves is point N Pareto efficient? So what I want to give you a moment to do is give you a moment to think about what we require for Pareto efficiency. What do we need in order for point N to be Pareto efficient? Take a moment to think about that for yourself. Okay, so having thought about that, remember that the condition for Pareto efficiency is that A's marginal rate of substitution must equal B's marginal rate of substitution. Okay, so let's think about that. Firstly, let's think about their price offer curves. We've got A's price offer curve from Z to N. What else we know is that at that price, she has an indifference curve, or he has an indifference curve, that is tangent to the price that he would be offered at that point. So at point N, there is the price. There's the price which is indicated with the price line slope minus Pn. And so For Adamo, he has an indifference curve which is tangent to that price line at point N. Moreover, for Beatrice, with Beatrice's price offer curve, we also know that Beatrice has an indifference curve, UBN, which is tangent to the price line at point N. Both of them have indifference curves that are tangent to the price line at that point. So, because both of them have indifference curves that are tangent to that price, what we see there is that they must have the same slope at that point. So A's indifference curve must equal the slope of A's indifference curve must equal the slope of B's indifference curve at point N. If the slopes of their indifference curves are equal, that means that their marginal rates of substitution must be equal. Remember that the marginal rate of substitution is defined as the negative of the slope of the indifference curve. So if the negative of their slopes are equal to each other, their marginal rates of substitution must be equal to each other. Also remember that for both of them, they set MRS equal to MRT when they were finding their price offer curves. So for both of them, MRS equals MRT for A, MRS equals MRT for B. Both of those are true at point N. Therefore, MRSA equals MRSB at point N. As a result, we have a Pareto-efficient allocation. Now, what we want to think about there is because the buyers and sellers are price takers and we made use of the law of one price, we know that the resulting allocation is sometimes referred to as a perfectly competitive general equilibrium. So this point N over here, we refer to that as a perfectly competitive general equilibrium. They're price takers and the price clears the markets, and they're following the law of one price. And we say that these are the conditions that we require for a perfectly competitive general equilibrium. Now, here's the thing. The model does not address the question of how did we get to the price Pn? How does competition determine this Nash equilibrium price Pn? So later in this chapter, we will drop the assumptions that people act as price takers, and we will think about how they might get to this price Pn rather than just simply taking it as given. The idea that price Pn might simply occur is one that basically comes out of this process called tâtonnement, which we spoke about previously with Walrasian. And so when we spoke about Walrasian and tâtonnement, Walrasian basically said, oh, okay, well, people would just throw out prices and they would arrive at the Nash equilibrium price Pn. He didn't call it that, but that's basically what he was saying. Now, the problem is that requires them to have gone through a whole bunch of prices in order to find Pn. And we then want to think about what are the processes that people could actually go through to find prices that would result in trades between the two of them of which they would both approve. That we'll do in later parts of this chapter.